So, in our last two videos, we learned some mathematics, namely integration and differentiation. You can click on the videos that are embedded in this video if you have not watched them in full. Today, we are going to look at an example that uses the mathematics that we have just learned. And just like Mr. Schrodinger, we will take the example of a cat and a mouse. You know, I cannot draw the cat and the mouse again and again because I'm a poor artist. So we will denote the cat with a red dot and the mouse with a blue dot. Ladies, please don't argue with me on that. To me, it's just red and blue. To you, it might be some kind of red and some kind of blue. To me, it's just red and blue. Anyways, let's come back to the problem. Let us say that the mouse is standing aside a wall, and the initial distance between the cat and the mouse is L, perpendicular to the wall. At the point when both of them spotted each other, the mouse started running with a velocity u alongside the wall, and the cat started chasing the mouse with a velocity v continually pointing towards the mouse. After knowing all of this, it is pretty obvious that the cat is going to follow a path which will look something like this. So, what is our job for the day? Our job for the day is to calculate the total time taken by the cat to catch the mouse. Let us take a point onto the path of the cat and calculate the relative velocity of the cat with respect to the mouse for that particular instant. For this instant, the instantaneous velocity of the mouse will be the component of the velocity of mouse alongside the wall onto the line joining the position of the cat and the position of the mouse at that instant. So, if we multiply this instantaneous velocity, this instantaneous relative velocity with the instant of time which we are talking about, we will get the instantaneous displacement. And if we integrate it from the starting time to the end time, we will get the value of the initial distance between the cat and the mouse. You can easily notice in here that there is not just the vertical displacement of the cat relative to the mouse. There is also a horizontal displacement of the cat relative to the mouse, since the mouse is also moving in a horizontal direction. So, to calculate the total horizontal displacement of the cat, we will calculate the instantaneous horizontal displacement for the position that we are considering in the first place. So it will again be the component of the velocity of cat in the horizontal direction times the instant of time we are talking about. And if we integrate it for the time interval starting from 0 and ending at t is equals to tau, we will get the total horizontal displacement, which is also equal to the velocity of the mouse times the total time consumed. We can clearly notice that in these equations, the only thing variable and time dependent is the angle. We are denoting it with alpha, making the sine and cosine of alpha as the time dependent or the function of time. So they will only remain under the integral, but so if you have watched my previous video, you might have already guessed that what we will do, we will take out constant of the equation, and then we will multiply it later. Okay, we will take out the constant and we will try to get the value of integral of cos alpha dt. Yep. You can clearly notice that in the first equation that we wrote down in the first place, we have a cos alpha there, and the value of integral of cos alpha that we have just found, we are going to use that while solving the first equation. So let's try to solve it. It would have been a piece of cake for you if you have watched my previous video, but in case if you know how to integrate, then it would still be a piece of cake for you to understand how I have solved this equation. So what we will do, we will split the primary equation into two parts, and then we will take out the constant from the parts and we will solve the integrals. Keep in mind that we need not to solve the integral of cos alpha dt. We are going to put the value that we have just found while solving the problem for the horizontal displacement. After applying the limits into the equation, we will solve the equation for the value of tau, and the value of tau in terms of L, U, and V will be our solution. So here is the solution that we are looking for, and thanks for watching.